Hello everyone, my name is Alex. I'm a fifth-year student at in the Wood Products Processing Program in the Faculty of Forestry here at UBC in Vancouver. And I'm going to tell you about my last co-op job I did this last summer, working for Plywood with West Fraser. A little bit about me to start. I grew up as a normal Canadian kid in my opinion. Out in the woods, fishing, I played hockey, I was a goalie, so that explains a lot. And right here is my grandpa, and he worked for Tolco for a while. He's been in sawmills all his life. He's really the reason why I'm here right now, talking to you about sawmilling. So I've worked 2 co-op jobs now. My first one was with West Fraser at their Slave Lake Veneer Division in northern Alberta, where I spent my time there. I shortened the length of peeler blocks and set new logging targets, as well as designed and built new downtime and quality control programs. Now, this last summer at Plywood, I did kind of the same thing as in Slave Lake. You know, I mean, do what you know. Shorten length of peeler blocks, but I also introduced moisture sorting for random width veneer at the green chain, which is what I'm going to be talking to you about today. So Plywood opened in 1951 as Western Plywood. They ran their first piece of veneer, and they still have it on site in 1951. It was bought by West Fraser in 2004 from Weldwood, Canada, alongside her sister mill, Williams Lake Plywood. And currently employs around 300 people, not counting contractors and other craftsmen that come in to help around do maintenance. Plywood makes standard sheeting, select sheeting, which is sold primarily in Canada. We keep most of the panels in Canada, but we also sell occasionally to the United States as well as to Japan under the JAS certified stamp. In addition to the standard certified products, they also make more specialized, more appearance grade kind of products, such as chalet sheeting and premium floor, which is called premium because it's absolutely dense. So the pitch I always get for it is this: if you step on it in high heels, you won't go through it. So you always hear that about it. So the plywood process can be easily broken down into 8 steps. You start off with your debarking and your bucking, where you take your long log and you cut it to length after removing the bark. And then the blocks themselves are placed into these big steam chambers, where the wood itself is heated to roughly 80 to 100 degrees Fahrenheit. Once it's heated, it's then placed into a rotary lathe, which takes that block and peels it out into a sheet, and then clips it into smaller sheets. So you go from a block to a ribbon to individual sheets. Those sheets are then taken over to dryers, which then take those sheets down from the regular green moisture content down to the dry content we need to use in plywood to assure for good adherence and to prevent blowouts. Some of those sheets will go to composing, where the smaller sheets, the off-size sheets, will be stuck together to make full-size sheets again. So that's to reduce waste primarily. Once all the sheets are ready, they're sent to the layup line, where they're taken, passed through a glue curtain, and then laid up by hand. Each sheet is handmade, and then put into presses, which cause the glue to cure. It's a phenol formaldehyde resin, which cures quickly. Once the panels are taken out of the presses, they're very hot, so we put them in hot stacks, where they cool down, and then they're sent to the panel saw, where they're cut to size in the finishing and grading step, where then they're sorted as either standard or select or cull or D grade. Once they're graded and puttied and all ready to go, they're sent to the strapper, where they're packaged and out to shipping, which then puts them on trucks and trains and sends them all over North America, as well as Japan occasionally. Now, this is a simplified process flow. See here, this is piles of veneer, and eventually, that's D-grade plywood. That's all the picture I have is D-grade plywood. Did a lot of quality control. This is a more complicated process flow. It kind of shows all the decisions. As you see, it's not as simple as those 8 steps kind of hide. There's a lot of complexity in making plywood. People don't really think of, I find. So, and it continues. I have 2 slides. I tried to keep it into one, but I couldn't. But that's just the way it goes. Now, when I arrived at Plywood, I was told, and I also found the biggest issue they were facing was dryer throughput. The simple fact was the lathe put out more veneer than the dryers could dry, and the presses pressed more than the dryers could dry. So in order to make up the difference, they had to buy purchased veneer, which is all good when the price of plywood's high and everyone's making money and everyone's happy. But when that price of plywood drops again, well, it's not so happy anymore. Which brings me to dryer number 3, which is it was bought used by West Fraser, and it's a 1954 Moore longitudinal dryer, for those of you who know lots about dryers. It's 5 decks, a single heat zone, which means that it's basically a big oven that we run the veneer through to dry it. At the end of the cross-up moisture meter, and it's very bare bones, very old dryer. It's full of holes. You can see it leaking, I think, in some of these pictures. All cases in point, it's seen better days, and I decided to see if I could get a bit more performance out of the old girl. Which brings me to green chain moisture sort. Because the simple fact is, the way to improve your drying performance is to improve the mix of what you're putting into the dryer. Now, before we just pulled all the random width sheets into their own carts and mixed them all together. We had heart with sap and sap with heart, and it caused a big variation in drying times. The dryer would adjust and slow down and speed up and slow down. So what I introduced was a simple moisture sort system. So I added 2 carts and had them sort sap and heart, just based on weight. They didn't have any technology to be able to sort it properly. So we just sorted by weight and by feel, and then ran them through the dryer separately. So as you can see, there's no heart bin down here, unfortunately, because of safety constraints at the mill itself. Very old mill, very tight. That's something you got to work with. So the initial runs of our first test runs were really good. Really, really good, actually. We saw an easy 20% uptick in performance overall without increasing our redry or our wets coming out the other end at all, which is just wonderful, because it means my ideas worked. But there's a few problems. For one, we weren't able to run at max speed because of the limitations on the outfeed of the dryer, which I'll show to you in the next slide. And often, well, not often, but occasionally heart runs were mislabeled in the data gathering machine as sap runs, meaning that I ended up having to dig through it, and I wasn't sure, looking at the runs, what was what. It made my life harder, but it made my life harder. This is the outfeed's limitation I was talking about. Now, normally when running heart and sap, with 2 off bearers, you sort the re-dry or the wet, and it goes into the center bin, with the dry going on the outsides, along with trash going off to the sides to be disposed of, turned into hog fuel. Now, the issue here is that when we run re-dry, which is when we only run the stuff that's wet, it goes through a lot faster, so we put 3 people on there, give them 3 carts to throw into, and we hammer it through. Now, we were running around re-dry speeds, running hard. This heart is already pretty dry, but we couldn't sort properly because you couldn't put 3 people here and have them not get tangled up with each other, trying to sort wets and dries and all. So wets and dries, they get tangled with each other. It was just a safety nightmare. Right now, they're looking at ways to get around it so they can run it even faster. But at the time of me leaving this position, they hadn't come up with any particular special way to do that. So what were the effects of sorting? How did sorting really improve besides increasing speed? Well, it increased the throughput. That's pretty obvious to see. You see your dryer start to pick up. It also offset the need to purchase dry veneer on the open market. Since now you're putting more wood through your dryers, you have to buy less wood on the market, so that saves you money there. So working backwards, I used data from 2016. I estimated that had we had the randomness sorted and run through the way we were using in this program, we would have saved the mill $240,000 that year. So for the cost of 2 carts, you're saving $250,000 a year, give or take. Now, as this is a co-op program and I'm there learning as well as working, there's a few things I learned. Like, no plan survives implementation. Now, the takeaway from that is not don't plan. It's that when you do plan, be flexy, be adaptable. Another one is getting buy-in for your idea. So getting people to come on board and really buy into your idea will help you in the long run because they'll be supportive and they'll give you help, rather than trying to force your idea through them with the whole, I know what I'm doing. You just don't want to, you're going to run into that, you don't want to do that. And the last lesson I really learned was learn to pick and choose your battles. I just found you get tired fighting every single battle that came up. So I just learned which ones you are worth fighting for and which ones you need to fight for. And the ones that you don't need to, don't do it. It's a waste of your time and effort. I'd like to thank a few people for their help of me working on this project. First one is Trevor Norton, my supervisor at Plywood, for answering all my endless list of questions I had for him. I'd like to thank Richard Branson as well for letting me go ahead with this project and just letting me mess around in his mill. That was really, really nice of him. I'd like to thank Darcy Henderson for placing me at Plywood. I'd like to thank Sonny Civic, the co-op. Darcy Henderson's the Caribou Regional Director at West Fraser, and he does all the co-op hiring. I'd like to thank Sonny Civic, the co-op coordinator at Wood Products Processing, for helping me get this job at Plywood. I'd like to thank Greg Smith for his help with kind of figuring out what I wanted to do for this presentation. And I'd like to thank all the number 3 dryer off bearers for, well, putting up with me for 4 months. And that's it. Thank you guys for listening, and go back to whatever you were watching before this.